Welcome to Lesson 4 in Unit 25, Science in St. Louis. In this lesson, students are going to look at the science behind a home run. They'll look at the balanced and unbalanced forces that cause a home run ball to change directions and go far, and then they'll also look at the energy transfer that occurs when a bat hits a baseball. During the Engage portion of this lesson, you'll show students a video of a home run. Then you'll pose the following questions to students, like what did you observe about the motion of the baseball, or what caused the baseball to change directions after the pitcher threw it towards the plate? In the Explore part of this lesson, students are going to answer the question, how do forces affect the motion of a baseball? Each group will get one squishy baseball. For the first test, you'll have students test balanced and unbalanced forces on the baseball. To do this, you'll expose the baseball to balanced forces, like nothing touching the ball. Another example of a balanced force, however, is when two students push on the ball at the same time with an equal force. The ball still won't move, so that's also a balanced force. And then finally, the unbalanced example will be when one student pushes the ball with their finger. In the second part of the Explore Lab, students will answer the question, how does motion affect the speed and direction of a baseball? To do this, they'll look at the changes of speed and direction when a collision occurs. They'll also discuss the energy transfer within this collision. In the Explain part of this lesson, you'll read the innings and outs of baseball, where students will learn about the concepts they saw in Test 1 about unbalanced and balanced forces. You'll then perform the smashing spheres demonstration, explaining energy transfer. The more speed that two objects come into a collision with, the more energy that will be transferred within that collision. In the Elaborate part of this lesson, students will watch a slow motion video of a high-speed baseball colliding with a baseball bat. They'll notice the change in shape of the baseball and the change in direction of the baseball, and they'll be asked to apply the concept of balanced and unbalanced forces in this collision. After watching the slow motion video, students will be presented with data to look at how the mass of a ball being hit by a baseball bat would affect the motion of the ball and the energy transferred. Students will specifically look at the energy transferred through the speed of the baseball. The more speed the baseball has after the collision means more energy was transferred. After students have analyzed and interpreted the data in this scenario, they'll discuss how this data represents a fair test, and then they'll draw a model explaining the forces acting on the ball and the baseball bat during the collision. To assess student learning in this lesson, students will answer questions about the energy and forces that occur during a home run collision. By the end of this lesson, students will have reviewed energy transfers in collisions, and they will have discussed the effects of balanced and unbalanced forces on the motion of an object.